Hello and welcome to the first video in the OpenCV playlist. So this is just gonna be a very basic video introducing you to the installation process as well as some basic functionalities OpenCV gotta offer. So before starting this video, let's hop over to our terminal to check that we have met all the prerequisites. So the first prerequisite for getting started with OpenCV is having Python installed. So I'm just gonna quickly type in Python version to check what version of Python are we on. Okay, it's 2.7.16, but we're gonna work on Python 3. So let's just type this out. Yep. So currently we are on Python's version 3.9.0. Another thing what we need is we need OpenCV. So I'm gonna pip3 install OpenCV slash hyphen Python in case if you do not have these libraries installed. And there you go. Since I already had them installed, so I'm getting this. But if you do not, feel free to go ahead and download them. Another very important library we're going to use throughout the duration of these tutorials is immutals. So go ahead and install that. And I even had that installed. So that requirement is satisfied. So first of all, I'm gonna hop over to my desktop and create a folder. Let me rename it to OpenCV hyphen Python. And I have this demo image. This is the image we're gonna work over throughout the tutorial. So I'm just gonna add it inside the folder and open this folder in my VS Code. So if you don't have VS Code installed, get it installed, as well as I'll give away the installation link in the description. So feel free to check that. So right now we're gonna create a Python file. So it's just the basics. I'm gonna name it basics.py, and there you go. So I already have immutals and OpenCV installed on my computer, but I need to import it inside this file directory. So I'm simply gonna use the import method and import the immutals library, and then import this CV2. All right. So now I have the image over here, but this demo.jpg, but I want this image to be a part of my basic script. So for that, I take a variable and name it image. Okay, now I'm gonna use CV2's inbuilt function, that is imread, to read this image. So either you can give the path of the image, or you can just give away the name. Since it is already in my directory, I'll rather just put in the name of the image. And yeah, so we have our image over here. All right, so it is inside this image function. Coming over to this image, basically every image or every part of the image is in the form of a grid, all right, which is represented using a numpy array. Every image has its own pixels with certain dimensions. That is where and every image has a particular height, a particular width, and a particular depth. All right, it can be the x and the y coordinates, and the depth signifies whether it is a grayscale image or is it a colored image. So since this is a colored image, and let's check what kind of image is it, I'm going to take a tuple here, and h being my height, sorry, yeah, h being my height, w being my width, and d being my dimension. And I'm simply gonna take this image variable, and whatever shape does that image have, or whatever dimensions does that image have, will automatically copy to these three variables. So if you want to check what are the values of these variables, I'm simply going to print each one of them over here, and let's just run the script. And there you go. This is the output we received, that is each of these values. uh, 384 being the height, 600 being the width, and 3 being the depth. That is, it is represented in a BGR format. That is the values of respective values of blue, green, and red. Since this is a colored image and it is not a grayscale image, we have the value of 3 over here. We'll deal with grayscale images in the later part of the section, but for now, we're gonna leave it as it is. So now I'm going to comment it out. Another thing which comes to my mind is, what if I want to access just this one particular value or one particular coordinate, and I want to access all the three BGR values of this particular coordinate or a point. So what I can do is take another tuple and have those three BGR values here, and take my image, because image is the variable which contains the picture, and just add random coordinates to it. So now I'm gonna print each one of them out. It's in caps, PGR, and let's see what does it return. All right, so this 100 and 50 are like the two coordinates. X-axis being 50, y being 100. So in this, whatever 50 was and whatever 100 was, that coordinate, these are this is the depth of those three coordinates that way. Okay, so that being done, another function or another thing which can be done using this is the slicing, or getting out the region of interest. So what if I just wanted the face, if I'm implementing a facial recognition algorithm, and all the other detail is just crap to me. So for that, we can easily extract the region of interest from a picture by providing the random dimensions. So for region of interest, I'm using the variable ROI, again image as my parameter, and you gotta put square brackets here. And again, I'm just entering some random dimensions. What do they signify? I'm gonna just cover. So these are the other two dimensions. Coordinates of the image being x is equals to 360 to y is equals to 60, and then x is equals to 420 to y is equals to 160. So the array has been cropped out using these dimensions, both the x and y coordinates of both the 2 points. And again, I'm going to use the same method, cv2.imShow. This time it's my region of interest. That means the only part of the image I actually need, passing in my variable which holds this value, and then using the wait key because we just don't want it to vanish out. So I'm using 1000 here, and let's just run the script to see what it has. Okay, so that vanished away pretty quickly, but that summed up what we were doing. We were just getting the coordinates of this guy's face, because that can be used in the pre-processing of further algorithms which are gonna cover in the later part of the course. So we have done resize, we have done cropping, we have done printing. Now what we need to do is resize our image. So when we talk about resizing, that can be easily done using the immutals library. All right, so I take another variable as resized and use import using the resize function of this particular library, pass in the image as an argument, and we just want the width of that image to stay the same, and rest of the dimensions can uh, manage accordingly. So we can have image over here, and then the width, and we want the width to remain constant, that is 300. And now I'm gonna just display it out on the front end. cv2.imShow, this is the resized image, and passing in the function, having it printed. Oh, sorry, I'm typing it again. cv2 dot wait. Let's wait for bit more time because last time just did not work out. Let's run this script again. And as you can see, the size of the image has changed. And you can see if I am moving through the image, you can see the different RGB values over here. Since the red part was, never mind, it just went away. So we've covered resizing, we've covered displaying. Another thing which another function which we can do is rotate an image. All right. So it can easily be done using the internal libraries. I'm simply taking a variable rotated. I'm importing the immutals library. Then I'm gonna call the rotate method, which is provided by the library itself, passing in the parameter that is the name of the variable which contains the image and the angle at which we want to rotate it. So we're using if we want to rotate the image at 45-degree angle, we are just doing -45. We can even do 45 depending upon the angle totally. Then again, I'm gonna just display it out. I am sure this is the rotated image this time. All right, passing in the variable, then printing it out. Okay, I'm writing it again. Never mind, we'll erase it. Getting back to the wait key, and let's wait a bit longer. Let's see what it has to return. As you can see, the image is rotated by a 45-degree angle. What happens if I just, rather than using -5, I use +45? What are we gonna expect? As you can see, it is just rotated in the opposite direction. All right, so we are done with the rotation. Now another very important function which we can use on this picture is actually blurring it, or adding some bit of Gaussian blur. So for that, I'm gonna comment this out. So you may ask, what is the need of actually, blurring out the details or smoothing the image? Smoothing was the word I was looking for. That is because if you're using multiple ML-based algorithms which just need some specific details, and there are some very unnecessary voices in the images, it can cause the algorithm a hell lot of difficulty and even increase the training time. So to avoid that, we use the technique of blurring the image so that while we are training the model on certain algorithms, it does not the noise or the things which are not needed do not does not interfere with the actual um, process of the algorithm. So Gaussian blur is a function available in CV2. As you can see, I'm gonna import that, and here I'm gonna pass my image as a parameter. All right, and we want the size of the blur to be 11 by 11. You can check the docs. We have to include the source, the size. So I'm keeping it the blur size being 11 by 11, and I want the blur to be from the center. Okay, now again the same process to show cv2.im show. This time it is a blurred one, and gonna return that. Wait for some time. mm, Wait key. Okay, and let's make it just a very long time. Okay, yeah, I made an error here. It has to be cv2. Let's run it again and see how blurred the image is, and only the important part of the photo is visible over here.